What's up, everybody? It's a beautiful day to write some code. Let's get right into it with Leet code number 104, maximum depth of binary tree. So given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. So in this example we have here, we are given this node 3. We see if we travel to the left, we can make it to a depth of 1. If we travel to node 20, we would make it to a depth of 1. And then we can continue traveling down to 7. We would see a depth of 2, and down to 15, we would see a depth of 2 for a final answer of 2. So anytime I'm given a graph problem or a tree problem, I'm immediately thinking, should I depth first search or should I breadth first search this tree? In this case, it's obvious we're going to go with a depth first search. A breadth first search would be level order traversing this tree, looking at the root node, then all of the children nodes in order of level. In this case, we're going to depth first search. So as we're traversing this tree, we want to keep track of our current depth. We want to start at this root node with a depth of 0. And then we're going to pick a direction, and we're going to go as deep in this tree in that direction as we could possibly go. So if we chose right, we would go all the way down to 7. And then if there was another one here, we would go all the way down there to a depth of 3. And then we're going to pass this 3 back up the call stack and figure out what to do with it then. So what are we going to do with this? Let's take a look back at our original node. So what is the max depth of this node? Well, the max depth is going to be the maximum between how far we can make it going left and how far we can make it going right. And we're going to recurse and do this for all of our functions. So once we get to this node 20 here of a depth of 1, we're going to say, okay, the max depth is however far we make it right and however far we make it left here. So the max, if we make it 2 going right and 2 going left, the max would be 2. Then we would pass this up to our root node and we'd say, okay, we could go, the max going right is 2, and we would find the max going left to be 1, and we would return 2 as our final answer. So we want to start at our root node, keep track of our current depth, and our answer that we're going to return up the call stack is going to be the max of however far we can make it going left and however far we can make it going right. Now, the only reason we're picking between left and right is because this is a binary tree that only has 2 nodes, a left node and a right node. If we were able in a normal graph to have another node, we would return the max of all of the child nodes that this root node has. All right, let's hop into the code here. We are looking at what our binary tree looks like. As you can see, we have a value, we have a left, and we have a right node. And we're going to fill in this function max depth that takes the root node. So the first thing here is that we want to keep track of not only our root node, but we want to keep track of our current depth as we traverse this tree. So we're going to define a helper function here. We're going to say define max depth helper, and this is going to take self, it's going to take our root node, and it's going to take our current depth, and then our main function is going to return self dot max depth helper, and we're going to pass in our root node, and now we know starting at our root node our depth is going to be 0. So now from within our helper function, we want to check our base case. So if we pass in a null node, we know we have reached the end of our depth first search, and we just want to return our current, whatever depth that we found, right? So we could say if our root node is none, if root node is none, then we can just return depth. This is going to be our base case here. Now, if our root node is not none, then we want to travel as far as we could go left, and we want to travel as far as we could go right, and then we want to return the maximum distance of those two. So we could say our left is going to be our recursion to the left. So we could say self left is going to be equal to self dot max depth helper with our root dot left. And we're going to increment our depth now that we are recursing to the left. So we're going to say depth plus 1. And we're going to say right is going to be the same thing here, except with our root dot right. And then now we're going to say return the maximum between left and right. All right, so let's double check from the top. What is our function going to do? We pass in this root node, and then we return our helper function with a starting initial depth of 0. So then we're going to say, okay, is our root none? If it is none, just return the depth. So if we're given an empty or one node, we're just gonna, or a null node, we're just gonna return that depth of 0. Otherwise, we're gonna go left, and then we're gonna recurse with a root dot left to depth plus 1. And then this is going to put us back up here. So we're gonna be looking at that left node, and we're gonna say, is this none? If it is, just return that depth, which is now our incremented depth. If it's not, go to the left. And then traveling back up the call stack, we're going to then travel as far as we can to the right, also incrementing our depth. And this is going to travel once again until it hits a leaf node, in which case it's just going to return that depth. And then from whichever node we are currently looking at, we're going to return the maximum of either however far we made it going left and however far we're going right. And this is going to be the overall max depth of our binary tree. So let's run it and see what we get. All right, let's submit our solution and see what we get. Fingers crossed. Return outside function. Because right here, this is not indented correctly. So if we scrape back here and then submit again, see what we get. Bada bing, bada boom, 4 milliseconds. That's twice as fast as last time. All right, if you found this video helpful, feel free to check out the channel for more. Thank you and have a nice day.